Welcome to the channel. This is a playlist to prepare you for a Physics 1 course, Intro to Mechanics, calculus-based or algebra-based. So either way, for now, I'll let you know when it's calculus-based, but everything is for both classes, and I will let you know if you need it or not, i.e. if you're in the calculus-based course. So this first video, we're just going to cover some basic stuff here, scientific notation and the units. These are both very important, and they will take points off if you don't use the correct units. They're real sticklers when it comes to grading tests. So we're going to first just talk about significant figures, or sig figs they're called. Writing scientific notation, just kind of how to go about that. Counting decimal places is really all we're really doing. Units in general, a few kind of different ways to represent units. SI units, which we use in physics always, and we stick to those, and I'll introduce those. And then the prefixes, which is related to scientific notation, but things like milli, nano, stuff like that, we'll talk about that, and I'll give you a comprehensive list here, and link in the description below. All right, let's get into it. So let's look at significant figures, or sometimes they're called sig figs for short. It's something you do, especially in chemistry and engineering, and they want you to round to a certain degree in physics as well. So let's just take a look at this thing, and I'm just going to write a number. So let's write 3.145719023. So it's got, looks like 9 places after the decimal point. That's quite a bit. And I don't really care about most of these. That's the whole point of significant figures. So if I wanted to write it to 3 significant figures, or 3 sig figs, the number would look like this. Just 3.15. We'll round up on that even number there. So 3.14, but there's a 5. So we'll round that guy up to 3.15. That is 3 significant figures for this number. Notice that this thing here is the number itself, and we've just rounded it, well, to 3 significant figures. What if it was 1 significant figure? 1 sig fig. Well, it's just 3. We don't need to round up, we round down, because 3.14, or I don't even care what's after the 1, if I'm rounding to 1 significant figure, it's 3.1 essentially, so that becomes 3 to 1 significant figure. That's pretty much it. It does get a little more. There is a little more to it, but you don't need to worry about it too much in physics. They really don't care that much and won't grade you that hard on it, if at all. Now, if you're doing chemistry or engineering or some other hard science, then they definitely care about that, so maybe get used to it, because there's all kinds of addition, multiplication rules, which we won't get into in this video, since it doesn't matter that much for the class that you're about to take. I want to say one more thing. If I got the number 2.031, let's say I want 2 significant figures for this number, so 2 sig figs. That's not how you say figs or spell figs. 2 sig figs becomes not 2, but we need to include that 0. So it is actually 2.0. The 0 is meaningful there. It's a subtle thing. Again, don't worry about it too much in physics. Just know how to round and understand that sometimes they're going to want significant figures, and that's it. Okay? So let's write scientific notation and learn how to do that. Hopefully this is somewhat a review. So if we want to write something in scientific notation, then we're going to use a power of 10. Let me show you. For example, if I have the number 384,000, big number, a lot of zeros, I don't always want to write that. What if it's a lot bigger than that? I definitely don't want to write all the zeros out. So you can just say, if I use 3 significant figures, which we just talked about, so that would be 3.84. So the idea for scientific notation is, hey, there's an inherent decimal point here, right? 384,000, 0.0000 forever, maybe. I'm going to move this thing 1, 2, 3, 4, 5 places to the left to make it 3.84. But of course, 384,000 is not 3.84, so I definitely need to make up for those decimal point, the movement of the decimal point, which means, hey, I just counted 5 to the left, so that means, well, this is 3.84 times 10 to the 5th. That's all it means. This number here, obviously that's 384,000, but this number is 384,000, or 3.84 times 10 to the fifth. Typically I have some units like seconds or meters maybe, S for seconds, meters. We're going to get into that in shortly. But this is all it is ever. Let's do one more example where we say, okay, now I have a number 0.000178. And now let's say, hey, I want two significant figures. This is where rounding comes into play. Well, it's going to be 1.8 times 10 to the negative, well, I don't know. I got to move the decimal point. So the decimal point's here. I got to move it 1, 2, 3, 4, 5, 10 to the negative fifth. This is 1.8 times 10 to the negative fifth. That's all you're doing. Count how many decimal points you move from the natural location, and then if you're going to the left, well, it's positive because I need the number to be bigger. And if you're going to the right, when you move your decimal point, well, you're going to throw a minus sign in the exponent, 10 to the negative fifth, okay? Please understand this. It becomes very important in this class. So let's spend a little bit of time talking about units. They are the things that we put at the end of numbers sometimes. So if I say that I drove 50 miles today, because I wanted to for some reason, well, the number that we're dealing with, a scalar, which we'll talk about in the next video, it's just that. It's a number. I drove 50. 50 what? Not 50 inches, 50 miles. This thing at the end, something very basic, hopefully, is the unit. It tells us and gives us some idea of what it actually means. Because driving 50 inches, that doesn't even make any sense. Maybe in your driveway, backing up for a very brief time. But 50 miles, that's substantial. That means something when I'm driving. The context is what matters. It's pretty basic. That's pretty much the idea. So there's basically two types of units. We kind of use SI, or metric. That's what we use in physics and chemistry and science in general. That involves millimeters, 2 little m's. Liters is a unit of volume. We have seconds, kilometers. The SI is very specific because kilometers is not actually SI, but I wanted to get you used to the notation and the idea. But the metric is kilometers, and really SI is meters. But we need to talk about that in the next few minutes here. But just get used to the idea that there is a metric system, and then kind of the British imperial system, they call it, or we can just call it the British system, which is what we use in America. Inches, miles, ounces, pounds, these are all not part of the metric system, but are part of the British units. We don't use these in physics, but you need to know there's a difference. So there's a conversion factor usually to go from inches to meters, for example. And you'll spend time getting into that. This is supposed to be a review. But the last thing I want to talk about is that the fundamental units in science, and physics especially, are time, length, and mass. Pretty much everything else is just a combination of these three. Typically, time is in seconds, but it could be minutes or hours or days. Those are all units of time. The SI unit is seconds, which we'll talk about in a minute. Length is in meters, that's the SI unit, and mass is in kilograms. Again, SI is what you want to get used to. I'm going to go through all that with you to make sure you're using the right units, because if you use the wrong calculation, then you'll get the wrong answer, which does make a difference. So, as we just kind of mentioned, SI units are a subset of the metric system, where the metric is millimeters, kilometers, all that sort of thing. But SI is a very specific meter, let's say. So as we said, we've got millimeters, we can have nanometers, we could have kilometers, km. All of these have different prefixes, which we'll talk about in the next section. But the SI unit of, these are all lengths, right? These are all distances or lengths, but the SI unit is actually just meters. And so we're going to talk about this in a minute, but prefixes, kilometer, kilo is 10 to the 3. Nano is 10 to the negative 9th, and so on and so forth. So I want to give you the list, and we will talk about each one of these, as well as provide a reference sheet in the description below. All right, so SI units, this is distance or length, same thing. Length and distance are the same. Now let's talk about time. Well, we could have days, years, minutes, of course. And we could also have stuff like nanoseconds or microseconds, just as we talk about different prefixes. But the SI unit that you always want to convert to is seconds. Whatever you're in, if the problem gives you, hey, it took me 3 days to do this, well, yes, you do need to convert that to seconds. Whatever the conversion factor is, you would go through it. And you would say, well, I'll do it up here. 3 days is equal to, well, 24 times 3 hours. Okay. And that's equal to 60 times 24 times 3 minutes, and so on and so forth. And then there's 60 seconds in a minute, so you do another 60 times 3. This is finally in seconds, or just S we use for seconds, okay? So that would be how many seconds 3 days is. And you want to be very comfortable with that. This is, again, a short review. I will try to get another video together to get you a good converting kind of method. It's pretty simple, but you do need to know how to do it, because you're going to be doing it a lot in this class. Finally, we're talking about mass. That's the last fundamental unit. And this could be anything from pounds to grams, ounces. All of these things are mass. Notice that these are not metric. The only metric one here is grams. This is British. The green here are British, which we do not use really, but I wanted to keep you aware of that, of course. So kilogram, everything needs to be converted into kilograms. Whatever you have, get it into kilograms. Same as you need to get it into meters, seconds, kilograms. These are the 3 fundamental units, okay? You're going to be getting into this a lot, so the more time you can spend on this now and not be struggling with it later, hopefully you already kind of understand it, but if not, it's okay. You just need to spend the time, because it's not going to go away, and every single problem you're going to do, literally every problem you do, is going to deal with this, okay? So please make sure you understand. The last thing we want to talk about is prefixes. And what do I mean by that? Well, let's say somebody says nanometer. The word nano is the prefix in red. And what does that mean? Well, it means 10 to the negative 9th meters. That's how we would write that. So if we wanted to write 6 nanometers, NM would be the symbol for this in math, and the words are nanometers. That's what NM means when you see it in the context of units. And you want to convert to SI. Notice that this is metric, and we need to convert to SI, or the standard unit. Remember, if it's length, it needs to go to meters, but nano means 10 to the negative 9th. So 6 nanometers is 6 times 10 to the negative 9th meters. And that's really all you need to know. You do need to know all the prefixes, of course. Not all of them, but for example, this list here is a pretty good start, where centimeters here, down here at the bottom, it's 10 to the negative 2. So these ones, pico, nano, micro, milli, centi, and they're all lowercase p, lowercase n. This symbol here is the Greek symbol mu. All right, mu, that's how we say it. It's a Greek symbol. You're going to use a lot of Greek in this class. Theta, stuff like that. That one's mu. It means 10 to the negative 6th in the context of units. Notice I did it all in meters here, but I could say grams or kilograms, remember, is the SI unit. But let's say you have 4 or 49 micrograms. Well, 49 micro, remember mu is the prefix for micro, so that's equal to 49 times 10 to the negative 6th grams. Micrograms, not micrometers. You don't usually talk about micrograms, but this is what it means. 49 micrograms, or 49 times 10 to the negative 6th grams. Okay? So, you don't need to know every single one, but you do need to know basically what's on the page here, especially these 3 and these 2. So those 5. Notice that we typically use a uppercase symbol for the greater than 0. Notice that it's 10 to the negative 2 for centimeters. But over here for mega, we have 10 to the 6th, and it's a capital M as the prefix, okay? Again, this is review, so this is not in depth, but you need to know this stuff for sure. And the sooner you learn it, just like before, the better off you're going to be, because you're going to be dealing with millimeters and milliseconds all the time if you're taking lab and even in problems, of course, and you want to convert to each one and make sure you're making the correct conversion, as in milli is 10 to the negative 3 meters, because you will get the wrong calculation and they'll definitely take a few points off on your tests if you're not using SI units. That's just the way they do it. You don't need to worry about sig figs too much like we talked about, but you definitely need to know this stuff, SI units. Thanks for watching.